You know, some of the biggest breakthroughs in science don't come from these giant 1,000-page books. Sometimes they come from moments of just incredible, shocking brevity. And today we're looking at one of those moments, a story that kicks off with a legendary supercomputer and a scientific paper that was literally only 2 sentences long. Let's dig into how a $70 million problem became a 6-second puzzle.
And this is it. This is the whole paper. Just 2 sentences. Back in 1966, 2 mathematicians, L.J. Lander and T.R. Parkin, used a supercomputer to blow a famous theory out of the water. And that single equation you see right there, that was the proof. With just that one line of numbers, they completely toppled a mathematical idea that had been standing for almost 200 years.
So what idea did they actually break? Well, it was a big one, from the brilliant mathematician Leonhard Euler. He had this idea called the sum of powers conjecture. Basically, he suggested that for an equation with, say, fifth powers, you'd need at least 5 numbers on one side to equal a fifth power on the other. But Lander and Parkin, they found a solution with only 4. Just like that, the conjecture was proven wrong. And finding that proof, that required an absolute monster of a machine. Yeah, this was not something you could just figure out with a pencil and some paper. Finding that counterexample meant running what's called a brute force search, which is basically just testing countless, and I mean countless combinations of numbers until one finally works. It was a grand challenge that needed one of the most powerful computers on the entire planet at the time.
The machine they used for the job was the CDC 6600. And if you adjust for inflation, in today's money, this thing would have cost around $70 million. I mean, this was the absolute peak of computing technology, a room-sized beast built for the most intense scientific calculations you could even imagine. And it took hours of processing time on this behemoth just to find that one single rule-breaking equation.
This is where things get really wild. The CDC 6600, that $70 million machine, ran at 10 megahertz. A modern laptop, it runs at over 3,000. So that multi-million-dollar, multi-hour task from 1966, how long do you figure it would take today? Any guesses?
And that's exactly what a group of programmers decided to find out not too long ago. They basically staged a rematch, the ghost of that $70 million supercomputer versus the everyday laptops that we all have now. The goal was simple: run that same direct search and just see what happens.
Seriously, think about that for a second. A task that was once at the absolute frontier of science, something that required a massive national investment and hours of computer time. What does that same task look like today?
Less than 6 seconds, that's it. On an Apple M2 laptop, a programmer wrote a really simple brute force search, the most basic, straightforward way you could possibly do it, and it found the answer in 5.9 seconds. What took a supercomputer hours can now be done in the time it takes to refresh a web page. It's just mind-blowing. But here's the thing. That's just hardware getting faster. That's almost too easy of an answer. The real magic, and the next part of our story, isn't just about having faster chips. It's about writing smarter instructions for those chips to follow.
This is where the challenge really turned into a race. As soon as the first programmer posted their 5.9-second result, others jumped in. And their goal wasn't to use a faster computer, no. It was to write faster, more efficient code to solve the exact same problem on the same kind of machine. And the path to that speed follows a few key steps. So you start with a simple brute force method, which checks absolutely everything. But then you get clever. You can make this search smarter so it doesn't waste time checking combinations that can't possibly work. And then for the biggest boost, you can pre-calculate all the fifth power numbers you'll need and just store them in memory. It's like giving the computer a cheat sheet so it doesn't have to do the same math over and over and over again.
And the results are just staggering. That initial brute force search took 5.9 seconds. Okay, but just by making the search loops more efficient, that time plummets to 0.4 seconds. Then you add in that pre-calculation cheat sheet, and it falls to an incredible 0.18 seconds. That is a 30 times speed improvement on the exact same computer just from writing smarter code.
But wait, there's one more hidden layer to this whole story. It's not just about the hardware or the code you write. The software you use to translate your code into instructions the computer can actually run, that's called a compiler. Well, that makes a massive difference too. And the difference the compiler can make is just wild. So using the same unoptimized code, a programmer tested it with different compilers. 2 of them solved it in about 8 seconds. Not bad. But a third one, Intel's IfX compiler, took almost 43 seconds. It just goes to show you that progress in computing is like a 3-legged stool. You need the hardware, you need the code, and you need the tools that bring it all together. So, let's zoom out.
What does this incredible leap in technology and technique really mean? Because it's a lot more than just a fun history experiment.
What this really tells us is that a monumental task, one that pushed the absolute limits of a $70 million machine, is now, well, it's basically a homework problem. It shows how unbelievably accessible immense computational power has become. And it's a perfect reminder that real progress comes from both faster hardware and the clever software we build to run on it. The cutting edge of one generation really does become the training ground for the next.
And all of this leads us with a final, kind of huge thought. We just saw a grand scientific challenge become a simple puzzle in the span of a single lifetime. It really makes you wonder, what are the complex problems we're wrestling with today in medicine, in climate science and physics that will become trivial? Things that are solved in seconds by the computers and the programmers of tomorrow.